Hey guys, it's Mr. Schmidt here, and in this video, we're going to look at topic 1.4, comparative advantage in trade. This would be pages 22 through 27 in your textbook. And so, really, what we're looking at here is another application of opportunity cost. So, we looked at that with the production possibilities curve, constant increasing opportunity costs, and here we're looking at how to apply it to trade between two individuals or countries. So, in terms of learning goals here, basically there's three skills that I want you to be able to take away. The first one is how to calculate absolute advantage. The second is how to calculate comparative advantage. And the third one is how to get terms of trade. And of course, the production possibilities curve is one way to be given this information, but I'm going to show you another way here in the video. So, absolute advantage is the trader that can produce more of the good or service or uses fewer resources to produce the good or service. In other words, you either make the most or you use the least resources to make a unit of that good or service. That's absolute advantage. Now, here, most of the time when you're dealing with absolute comparative advantage terms of trade problems, you're typically given a table like what I have here on the screen. And you're going to be given two traders, in this case, the United States and Mexico, and you're going to be given two goods or services, in this case, corn and wheat. Now, what makes it a little tricky is you have to know whether it's an output problem or an input problem. So, an output problem is a situation or a table in which you are given the maximum number of each good or service each trader can produce. So, in this case, it's an output problem because we're given how many corn bushels or wheat bushels they can make with some fixed amount of resources. So, in this case, the United States can produce 20 corn bushels or 40 wheat bushels. Mexico can produce 5 corn bushels or 15 wheat bushels. So this would be an example of an output problem. An input problem, on the other hand, in this case, we have a new table with France and Spain. And you're going to notice on this table, before I go any further, and the table before, that I've left some space over here. That's on purpose. So when you draw your table, make sure you include that space because we're going to fill that in later. So an input problem is a situation in which you are given the amount of a resource it takes to produce a unit of the good or service. Remember, way back in topic 1.1, not so long ago, we talked about how input is another term for resource or factor of production. So in this case, this is how many hours, man hours or labor hours, it takes to produce some unit of grapes or some unit of olives. So in this case, France takes 3 labor hours to do grapes, 1 for olives. In Spain, they need 1 labor hour to make the same amount of grapes, 1 labor hour also to make a certain amount of olives. So, with that in mind, let's do a little practice here. So, back to the United States Mexico table, which country has the absolute advantage in corn and which one has it in wheat? So, take a second, pause the video, and see if you can figure it out, and then come back. So, the correct answer here is going to be the United States for both goods. Why is that the case? Because in an output problem, you're looking for the bigger number. With the same amount of resources, the United States can make 20 corn bushels, Mexico can only make 5, and the United States can also make 40 wheat bushels, whereas Mexico can only make 15. So the United States can make more of each good than Mexico, so they have the absolute advantage in both goods. And so what you see here is that, yes, it is possible to have the absolute advantage in both goods. All right, let's do it again, this time with the France-Spain question. So which country has the absolute advantage in grapes and in olives? So pause the video and see what you come up with. So the correct answer here is Spain has the absolute advantage in grapes, and neither country has the absolute advantage in olives. The reason it's Spain for grapes is because they take less time to make grapes than France does, right? So with an input problem, and you see why it matters whether it's an output or an input problem. With an input problem, you want the lower number because that means you're using fewer resources. So in this case, Spain uses a third of the same amount of labor hours that France does. Now, with olives, they use the exact same amount of time. And so, therefore, neither of them have the absolute advantage. You have to do it better than the other country or trader in order to have the absolute advantage. So, with that in mind, let's go to the second of three skills, and that's comparative advantage. So, comparative advantage is the trader that can produce the good or service at the lower opportunity cost. Because if you look at absolute advantage, and I think the Mexico US example is a really good one, the United States does both of these things, corn and wheat, better than Mexico. And so the question is, why would the US ever trade with Mexico if the United States does both things better? And the answer is, well, it's because Mexico is going to have a lower opportunity cost in one of those two goods. They can do it relatively cheaper than the United States. And so what economists would say here is that you should produce the good or service where you have the lower opportunity cost and trade for the good in which you have the higher opportunity cost or a comparative disadvantage. So let's see this in practice. In order to do this, we need to be able to calculate opportunity cost. And as you saw with absolute advantage, the fact that it's an output or an input problem is going to make a difference here. So for output problems, you're going to take the number in the trader's other box divided by the number in the trader's current box. And if you're like, what are you talking about, other current box? Well, let's take a look at this. So with other versus current box. So for example, let's say I want to know the United States opportunity cost for producing a unit of corn. So that means I'm in this box, right? I need to fill in the opportunity cost here in this box next to 20 bushels. That's where I'm going to put it. So this means that the current box we're in is this one where my arrow is. And that would mean, excuse me for the notification, but then that would mean that wheat would be the other box for the country, right? Because I'm currently in this one because I want to know the opportunity cost of the US producing corn. Whereas I'm not looking at wheat right now, so that's my other box for the US. So if we go back to the formula, it's other box over current box. So it's going to be 40 divided by 20, which is going to be 2. Now, 2 what? Well, it's going to be 2 bushels of wheat. Why? Because if I'm producing corn and opportunity cost is what I give up, I'm giving up wheat. So I'm losing 2 bushels of wheat. And then if we look at the other side, if this is my current box for the US, then this has to be the other box for the US. So it's going to be other over current 20 divided by 40, which is a half. Half of what? What am I giving up to produce wheat? Corn. 1/2 corn. And that's what I show right here. So it takes so what this means in the green is for every 1 unit of corn, 1 bushel of corn, let's say, I have to give up 2 wheat bushels if I'm the United States. Like I cannot produce those 2 wheat bushels. And then if I am producing 1 unit of wheat, I'm giving up half a corn bushel. So, to see if you get it, try it with Mexico. What is Mexico's opportunity cost for producing a bushel of corn and a bushel of wheat? Pause it and then see what you get. All right, the correct answer here is going to be 3 wheat bushels from Mexico and then 1/3 of a corn bushel. Why? Well, again, it's other over current. What's in the other box? 15. What's in the current box? 5. 15 divided by 5, 3. What do I give up to produce corn? Wheat. And then the reverse is true over here. 5 divided by 15 is a third of a corn bushel, because I'm producing wheat. All right, so now let's go ahead and look at who has the comparative advantage in corn and in wheat. So how do we figure this out? Well, remember, if we go back a couple slides, remember, comparative advantage is who can do it at the lower opportunity cost. So if I come back to, and I don't want to go too far, right, there we go. So which country has the comparative advantage in corn? Well, if I look at my corn column, the US gives up 2 wheat bushels, whereas Mexico gives up 3. I would rather give up 2 wheat bushels than 3. So who's giving up 2 wheat bushels? The US. So the US should produce corn. Now on the other side, with wheat, notice that Mexico gives up only a third of a corn bushel, whereas the US gives up half a corn bushel to produce the wheat. 1/3 is less than 1/2, and so Mexico has the comparative advantage in wheat, whereas the US has the comparative advantage in corn. Okay, so one tip that I will give you here, and I'll skip a slide here, is actually a couple slides. Well, let's go ahead and go to this one, then we'll go back to the other two. It's fine. Going a little out of order, but neither trader has a comparative advantage in a good or service for which the opportunity cost is the same for both traders. That's one thing to keep in mind. The other is that you cannot have a comparative advantage in both goods. So in our US-Mexico example, because the US had the comparative advantage in corn, we know Mexico must have it in wheat, unless their opportunity costs are the same. And so a vocab term I want you to be aware of here is called specialization. It's the idea of producing one good or service and trading it for a different good or service. So on our example, we would say that the US would specialize in corn, and we would say that Mexico would specialize in wheat. And so therefore, a trader should specialize in the good or service for which they have a comparative advantage. So that's output problems. Now let's look at input problems. So for calculating the opportunity cost in an input problem, you're basically going to do the opposite of what you did in an output problem. You're going to put the current box on top and the other box on the bottom. So I'm going to go ahead and give you the France-Spain input problem again. And this time, I'm going to have you go ahead, pause the video, try to find the opportunity costs for each country, for each good, and then we'll see if you're right. So the correct answers are going to be for France, it's 3 olives and a third of a grape. How do we know? Well, if this is my current box, then it's 3 divided by my other box, 1. 3 divided by 1 is 3. What do I give up to produce grapes? Olives, 3 olives. And then the reverse. Okay, 1 divided by 3 is a third. What do I give up to produce olives? Grapes. And then for Spain, it is going to be 1 olive and 1 grape, because it's 1 divided by 1. So even if you messed it up and put the wrong one on the top and bottom, you still got the same answer, 1 olive and 1 grape. And then, of course, we can look at which country has the comparative advantage in grapes and olives. So again, now this part is the same no matter whether it's output or input. We're looking for the lower opportunity cost. And one thing I didn't mention is the labels here, because you may have put, when you did the labels, labor hours. It's not labor hours. It's still going to be the good or service for the opportunity costs. So with that out of the way, which country has the comparative advantage in grapes? Well, I would rather give up 1 olive than 3 to produce grapes. Because Spain gives up 1 olive, they should produce grapes, and therefore France should produce olives because they give up fewer grapes, just like that. All right, and then finally, let's look at terms of trade. This is how much of one good or service a trader should accept in exchange for another good or service, right? So in other words, like it's kind of like a negotiation, right? I'll give you one of some good that I'm producing for a certain amount of the good you're producing, right? So let's look at this in context, right? So, in other words, how many olives should Spain accept in exchange for one grape? Because remember, we said that Spain should produce grapes and France should produce olives, right? So Spain's thinking here, okay, well, if I'm going to give France my grapes, well, then how many olives should I take? And this is the answer. It's going to be one grape for at least one olive and at a maximum of 3 olives. Now, how did we get that? Well, what you do is the quick and easy way is to say, okay, what good or service is Spain producing? Grapes. So go ahead and you write one grape. Okay? For, and then you're going to put blank to blank, and then whatever good or service that country wants. And so Spain wants olives in exchange for the grapes it's making. Now, how do we get the numbers in the blanks? Well, this is where having the labels with your numbers is so important. Because in this case, we're looking for any label with the word olive that is in parentheses. And so here's 1 olive, and then here's 3 olives. And then you make that a range. And so that's how we get one grape for 1 to 3 olives. Now, why do we put a maximum of 3? Well, we're assuming France isn't stupid and we know that France is probably not going to give us more than 3 olives for the grape. We put a minimum here because anything less than that is not going to be good for Spain. Okay, it's going to be worse for Spain, and Spain's going to be taken for a ride if they accept less than that 1 olive. So let's try it again. How many grapes should France accept in exchange for 1 olive? So go ahead and pause the video and see if you get it. All right. So the correct answer is 1 olive for 1/3 to 1 grape. So what is France want producing? Olives. What do they want? Grapes. So where's grapes in my table? It's right here. And so I set it as a range, 1/3 to 1. So it's 1 olive for 1/3 to 1 grape. And if you notice, that's the reciprocal of what we did here.